some of you must have worked on panel data, right? So it is basically a combination of both time series data and cross-sectional data, right? So what is cross-sectional data? It's basically data collected at a single point in time across different entities, right? So entities could be a firm, could be individuals, it could be a country, it could be a particular region, right? We have taken one example here, say crime rates for 28 states in India for a given year. If you capture that sort of data, that is a cross-sectional data, right? What is time series data? It is pretty simple. Data collected over time for a single entity, right? For example, GDP of a country, right? Collected over several years, over several quarters. So if you mix both, then it becomes panel data, right? It's a data set that includes observations of multiple entities over time, right? So in panel data, we often come across these two terms, balanced panel and unbalanced panel, right? So what is the basic difference? The basic difference is in case of balanced panel, all cross-sectional units have same number of observations. Say, for example, recently I was working on a research paper wherein I was working on Indian banks, right? That is how the ESG practices of Indian banks are impacting their performance. So getting ESG data is always a challenge, and in Indian context, we have very few numbers of listed banks, right? Say for example, Bandhan Bank. So it started somewhere around 2016, but my data frame, or not data frame, rather the sample period was 10 years, say from 2013 to 2022. So if I try to include Bandhan Bank, then definitely it won't have ESG scores for the year 2013, 14, and things like those years, right? So in that case, what happens if I still include Bandhan Bank in my sample? Then it will become unbalanced panel. That means for some banks, I will have data for 10 years, and for some banks like Bandhan banks, I will have data for less number of years. So in that case, the data will not be balanced. And later on, I will discuss, especially when we'll be discussing the dynamic panel, that if you have unbalanced panel, it can create problem. So what I did, I dropped Bandhan Bank simply just to keep the panel balanced, right? So that's the basic difference, balanced and unbalanced. Then also we come across these two terms very frequently, short panel and long panel. This is also pretty simple. What is short panel? Number of cross-sectional entities, that is N, is greater than the number of time periods. Suppose you are working with a data wherein you have, say, 50 banks, right? And you have collected the data for, say, 10 years, right? So your cross-sectional units, that's the banks, that number is more than the time period. So it's a short panel. In long panel, what happens? Suppose you are working with only 5 entities and your data is for 15 years, right? So that becomes long panel. And as we proceed, we will get to know that the estimation techniques that you use might vary depending upon whether you are working on short panel or long panel, right? So generally what happens in long panel, you have the time series component more stronger than the cross-sectional component, right? And in short panel, what happens? The cross-sectional component is stronger than the time series component, right? And in accounting and finance, or especially in our commerce domain, those who work in research papers, we mostly work on short panel, where we have many firms or entities, and we have data on some 5-10 year data, right? So what is so fascinating about panel data? Why do we, use panel data model? Why not restricted restricted to only the time series or only to cross-sectional data, right? So the first thing that is important for panel data is the heterogeneity, right? Because you are including different individuals, farms, states, countries, right? And over different time periods. So you can bring in much more heterogeneity into your analysis. That is absolutely very, very important, right? Then if we go by what the famous author Baltagi says, uh, according to him, panel data gives more informative data, more variability, less collinearity among variables, and more degrees of freedom, and hence more efficient, right? And third point that makes panel data very, very important is the dynamics of change, right? So if you look at a particular variable over different cross-sectional units, how that varies, then you are ignoring the fact that the variable might change over the years or over time, right? At the same time, if you look at any particular variable over a multiple, over multiple years, then you might ignore, or you may ignore, or actually you are ignoring the variation in that variable that might occur in cross-section data, right? So dynamics of change, if you want to really incorporate in your analysis, then panel data is the data to go for, right? And I have given one example, right? That if you simply look at time series data or panel cross-sectional data in isolation, then you may not do analysis that panel data would allow you to do, right? For example, you might be interested in examining how successive revisions in minimum wage under the Monrega Act influence employment patterns, migration rate, rural consumption across different states. So here you need not restrict yourself only to the time series pattern or the cross-sectional pattern, but if you combine both of them, then it will become much more robust and comprehensive for your analysis, right? So now, as I earlier said, that our focus will be on application, right? So, and in business schools, we generally take that case study based approach, right? So we will actually approach this whole panel data analysis from a case study based you know method, right? So I will take one comprehensive illustration or comprehensive data set, and we will run all the static panel data models on that particular data set, and we'll see how to improve the result, right, as we proceed, correct? So I have already given the data set in the WhatsApp group. I would request everyone to save that in your desktop. Have you already done that? If you have not done that, please do that, because very soon we will get into R and we'll do the analysis on that particular data set. Okay, so you may do that as I proceed. So what we have done, or rather what I have taken as data set, is a very famous data set. It was actually collected and compiled by Professor Mosi Kin, right? And this data set is available in another famous author in the field of econometrics, that is William Green, right? In the book Econometric Analysis, it is available. I have taken that data set and will be using that data set for developing the panel data models, right? And let us understand what is this data set all about, or what all variables are there. It's basically analyzes cost of 6 airline firms for a period of 1970 to 1984. And you can see that there are 6 firms, that is 6 airlines firms, and 15 years of data. So the total farm year observation is equal to 90, right? So what are the variables that you have? I will show you the Excel sheet, but let me just complete this. The variables are defined as I is actually denoting the airline ID, E is the year ID, right? Q is the output measured in revenue passenger miles, which is basically an index number. Those who have worked on airline industry, you know that revenue passenger mile is um, a standard measure of output for airline. So it is basically a composite unit, revenue passenger mile, right? But in this data set, it is expressed as an index number. So it basically means they have taken one year's revenue passenger mile as the base, and they have expressed the other year's number, relative to that particular number. That's the basic concept of index number, right? And then they have total cost, which is measured in $1,000, right? Then fuel price, another variable. Then load factor. Load factor is basically the average capacity utilization of the fleet, because every time the flight may not be 100% full. So what is the load factor? That is, what is the capacity utilization? Is it 90% capacity utilization, 95%, 80%, and things like that, right? So what we basically want to do, we are interested in finding out how total cost behaves in relation to output, fuel price, and load factor. Basically, in short, we want to estimate an airline cost function, right? Okay. So what is our dependent variable here? Total cost. And our independent variables are output, fuel price, and load factor, right? So if I ask you a question, please feel free to interact. How do you go about estimating this cost function? Would appreciate if some of you contribute to this discussion, please. How do you go about estimating this cost function? What is the approach you will take? Anyone? Any input? So you have 6 of firms and 15 years data. Yes.
Yes, sir.
Anyone?
Sir, cost function is the dependent variable, and it depends upon factors of production.
Okay, but here it is specified, right? 3 factors that you need to take into consideration. But
So
how
these
would
are
you go about it? That means regression, but how? Means will you have regression for every year, or will you have regression for every company or every airline? How would you go about it? That is the question.
So definitely heterogeneity exists here because every company is different from other. So
Okay.
I mean, we can talk about dummy. I mean, creating dummies is one thing we can do.
Okay.
Uh,
Okay, you are thinking in the right direction. So let me just elaborate on this. So we can estimate the cost function for each airline using the 15 years data. So that is a time series based regression, right? But is it a good idea? This can be done using OLS, no doubt about it. But we will have in that case 6 cost functions, right? One for each airline, correct? So I'm, creating 6 or estimating 6 different functions for 6 different, airline, right? That is one approach. But if I take that approach, it is flawed, right? Because we are neglecting information about the other airlines which operate in the same regulatory environment, right? I'm just having 6 different cost function for 6 different companies, right? But they are working in the same industry. So that dynamics is not getting captured in this approach. So this is not the right approach. The another approach that someone might think of, which is also not a great idea to proceed with, is to estimate cost function for each year using 6 cross-sectional units. So in that case, you will have 15 regression equations, right? Because you have correct. So we will have 15 cross-section regression, one for each year, right? But this definitely does not make sense because we will have only 6 observations per year. And we are already having 3 explanatory variable and 1 intercept term. So what about your degree of freedom? That will go for a toss, right? So we cannot do meaningful analysis using this approach either, right? So what are the options there? So there are, 4 popular options that we can explore to model this cost function. First one is pooled OLS modeling. We'll talk about all these models in detail. The second one is the fixed effects list square dummy variable approach. This is what Mamo was talking about, right? Then fixed effects within group model we can try. And we can also try the random effects model, right? We'll cover all this model in detail. We will estimate everything, right? So in brief, pooled OLS model is basically we'll simply pool all 90 observations and estimate a grand regression. We'll neglect or ignore the fact that we have a panel data, right? We'll simply pool them and do a regression. Yes? Anyone is asking anything? No. Second is here, in case of the second approach, we'll pool all 90 observations, but allow each cross-sectional unit to have its own intercept dummy variable. That means, as ma'am was talking about, that every company is different. So we will represent that individual heterogeneity in the form of individual dummy, right? I will explain all these things just to give you a brief on each of these models. Then we can have something called fixed effects within group model. Here also we'll pool all 90 observations, but for each airline, we express the variable as a deviation from its mean, right? D-mean, we will run the regression on the D-mean values. We'll talk about all these things. And finally, we can also explore random effects model, wherein we allow each airline to have its own intercept value. And we assume that the intercept values are random drawing from much bigger population of airlines. I know at this point, many of the things that are mentioned here in this slide may not be clear. As we work on the data and estimate the model, it will be clear for sure. Okay, so let me proceed. So first we will take a look at the pooled OLS regression. Before we proceed, or before I proceed, let me tell you this is not a very good idea, but as a part of the whole structure of this FDP, we need to cover this model as well, because we will build on to this as we go along and discuss the other model, right? So you can think of a model of this sort, right? Where cost is expressed as a function of the output, that is Q, and then the fuel price, PF, and the load factor, right? And you have the error term, correct? And here I is running from 1 to 6, that is 6 farms, and T is 1 to 15, that is 15 years of data. The interesting thing that you need to observe here, what is the assumption, implicit assumption here? You are assuming that the intercept, which is beta 1, is same across all cross-sectional units, that is the airlines in this case. So what does that mean if we assume that the intercept for all the companies or all the farms is same? What does that particular assumption mean? It simply means that we are assuming there is no difference across different companies or farms in this case, right? And this is a very unrealistic assumption. We cannot maintain this assumption, right? Very difficult to defend this assumption. Correct. Now, if you understand little bit of if you want to take a look at this particular model from the mathematical point of view, then what is this beta 1? It is basically the intercept. How do you interpret the intercept? It is nothing but the value of the dependent variable when all the explanatory variables are equal to 0, right? Yes or no? So think as this. That means even if you do not have any output, there is no spending on fuel, and obviously there is nothing like capacity utilization. If that is a scenario that you are thinking about, still each airline will have some cost, right? That is getting captured there. And this is expected to vary across different companies, right? Yes or no? It is expected to vary. But here implicitly we are assuming that it is going to be same, right? And in fact, we are ignoring the fact that each firm might be different, might have some individual, heterogeneity. Okay. Is this point clear to everyone, what I just spoke about? Yes or no?
Yes, sir.
Sir,
Is it clear?
can we say this as a kind of fixed cost notion? Isn't it?
Yes. Correct. Okay. But that amount will vary from company to company, right? Yes or no?
Exactly.
Yeah. So if we assume that that is constant for all the companies, that is something flawed. We cannot defend that assumption, right? So that is the basic problem with pooled OLS regression, and that creates a further problem. I will soon explain that problem, right? So now we have to get into R, and we'll have to estimate, and then we will get back here and try and make some sense out of all these things, right? Okay, so let us now proceed to R. I think all of you have this R and R Studio installed, right? And you can work on R and R Studio right away simultaneously with me. Yes or no? At least some of you can do it. Yes. So that would be good, because see, it is we don't have gaps in between, right? So basically we do not have time to do the exercise, or I cannot give you assignment, right? So we have to do it simultaneously. If possible, please do it. That will be helpful. Okay. You already have the data with you, right? Yes or no? Please open your R Studio, and you can use the chat thing also for any point that you want to raise or anything, right? So is it have you opened your R Studio? Yes? Yes or no, please?
Yes, sir.
Yes, sir.
Yes, please. I would strongly recommend please try to do it along with me, right? And whenever required, I will give you the scripts in the WhatsApp group. From there, you can just copy and paste. That is absolutely fine, because it is not really possible to remember all the codes, right? So you will always have access to the code, right? Okay. So the first thing that you need to do is you need to create a folder in your desktop. Name that folder as FDP_panel and save it. Okay. And the dataset that I have given, please save that dataset in that particular folder. Please do it, everyone. Please create one folder in the desktop. Name that folder FDP_panel, and the dataset that I have shared, please save it in that particular folder. Okay. Now I will, once this is done, please confirm. I will do the most important thing before you start working on R. Most of us, overlook this part and straight away, import the data and start working on it. That's not the right approach. You need to first set your working directory, right? Have you done the first step, that is folder creation and saving the data set within that folder? Yes or no? Is it done? Please respond. Done?
Yes, sir.
Yes,
Yes.
Yes, sir.
Okay.
Yes,
Please.
sir.
Okay, good. Now, how to do this, how to set the working directory, right? So you need to go to session. Can you see? You need to go to session, right?
Yes, sir.
I will talk about the other thing later. First, let us do the first thing first. You go to session, right? Then go set working directory. Choose working directory, right? And wherever is your that particular folder, wherever you have, right? So that you select. Okay. It's already done for me, so I'm not doing that. So what you do, you go to session, then set working directory, then choose working directory and navigate the desired folder and click open. Okay. Is this done for everyone? Yes, or
Yes.
no? Yes. Please confirm whether you are able to do it or not. Like this, right? Okay. So you have your folder in the desktop. Like this, right?
So, but
And click
X,
open. Is it done for
so
everyone?
that
Yes.
Excel, the Excel file, it is not visible, sir. I've stored it in the folder.
So that is not a problem now. It will be visible. Don't worry. First do this step.
Okay.
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 First set the working directory, right? If you are done, then you try this. Get. So now what you have to do now, let me tell you, in R basically you have one space where you write the codes, right? And then you have this console where whatever codes that you are giving, the outputs will come, right? So how to start doing the coding? Go to file, right? New file, new file, and then R script. Okay. A new R script, page will open, right? Correct? Are you able to do that, everyone? Especially those who are working in R for the first time. Yes or no? Yes. Please respond.
Can you repeat the steps, sir, please?
Very simple. Go to file, new file, then R script. Click on R script. Okay.
Yes, thank you.
Okay. Once it is done, then in your R script, you write get like this. Just type like this as I am showing. Get, and then this double bracket will come. Get WD, then this will come. Okay. Right. And then you have to run this code. This is the first code that you have written. Get WD, open bracket, and then run. Okay. Fine. Is it clear, everyone?
Yes, sir.
Yes. Okay. Let me also do it quickly for head directory, choose directory, right? then run this. Okay, so if you do this, get working directory, this will show you the path for your working directory. This is the first step that you must do before you start working on any R script. Okay, is it clear? Everyone could do this? Yes or no? Please, we will take.
Yes, sir.
This is a very simple step, but it's very, very important. Okay,
Yes, sir.
done?
Yes, sir.
Now, next is what is R package? That we need to understand, because frequently we'll be using R package. It is nothing but a collection of functions, data sets, and documentation bounded together to extend the functionality of R. So basically, this is where you will have all functions, data sets, and documentation that we'll be using for doing the analysis using R, right? Once you have got at least this understanding, next we will do what is called how to import data in R. It is most important thing. So there is one easy way, that is you can import using the menu-driven method, or you can import using code also, right? I would recommend to learn the importing data based on code, right? It will help in future, right? So to import data, you have to see the data that you have is Excel file, yes or no? So you have to install a package called read Excel, right? So how to install a package? In R, if you want to install a package, you have to type install.packages. So let me just show it to you quickly. Install. So once you start typing, this will come. Then you press tab. Okay. And what is the name of the package? That should come within double quote. That is read Excel. Okay. Read Excel. Please do it, everyone. And then you can select somewhere any part in this particular code and click on run. You can select the complete thing and click on run. That is okay. Or you can just place your cursor somewhere here and just click on run. Okay. Please run, everyone. Quick. We'll go a little slow because there are many participants who have not worked on R before, and then we will pick up the speed once the basic steps are clear to everyone. Okay, is it done, everyone? Are you able to follow me? Yes or no?
Yes, sir.
Install.packages, then open bracket within double quote read Excel. So your package is installed, right? Once installation is done, then the next step that you need to do is to call that package or load that package. It's like you have many cars in your basement garage, right? But today you want to drive one of those cars, so that should come in front, right? It's like that. So you have the package and then you call that package, because you might have installed several packages, right? As you go on, you will install several packages. Now you will be using only this, so you call it. That is called load the package. So how do you load that package? Library, open bracket, then read Excel. That's the name of the package. But here you do not use the double quote. Okay, just do that. Everyone, please do that and run the code.
Can I just go into tools and click install package there I can do?
But do it in this way. Avoid menu-driven things to the extent possible. Because I'll show you the other approach, which is far more easier. But this is useful because it will help you later. Please do it. It's not a big thing. Just library, read Excel. Okay. Done. Please do it. And if you want, I can just copy this and paste it in the WhatsApp group also. From there also you can do it. That's not a problem. But follow the steps. That is important. Okay. Are you able to do this step, everyone? Yes or no?
Yes, sir.
Yes, yes. Okay, good. Next, what is the next thing that you need to do? You need to read the Excel file. Make sure that you have put the Excel file within the folder that you have created in your desktop. Okay. So what is the command that we will give for this? Data is equal to read underscore Excel. Please do it, everyone. I will just show it what I'm talking about. Data equals to read underscore Excel. Once you type, automatically this comes, just press tab, right? And this bracket will open, and within that bracket, double quote. After doing the double quote, if you press tab, automatically what is there inside your working directory will be shown, right? And then click on tab. So it has come. Can you see what I have done? Are you able to follow me, everyone? Yes or no? Should I show it once more?
Yes, sir. Once more.
Once more. Very simple. What I'm saying is type data equals to read underscore Excel. Then this bracket will open. Or if it does not open, you type. And then within the bracket, put double quote. And you place your cursor in between these two double quotes and click tab. It will show you all the files that are there in your working directory. And you need which file? Airlines cost. Okay, just select that, then tab, press tab, it will come. Is it done, everyone? Are you able to do it?
Yes, sir.
Yes, yes. Okay. So once this is done, then what you need to do, you just need
And
to
this
run
will
this code.
happen. This will happen when we will write the code for the directory
Yes,
get.
yes, 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 yes.
Can
So
you
first
please
of all, you
scroll
have to
up?
first
Can
of
you
all, you
please
have to
scroll up that get
first of all, have you created the
get
directory?
WD? Yes, sir. Yes, I have done that.
You have created the directory, right? So, and you have put the data set within that directory.
Yes, sir.
Yes,
Yes.
yes, yes. Then it will work. Not a problem. Okay. So once this is done, then you just need to run this code. Please do that. Run the code. I'll just delete one and run the code. Once you run the code, then you see your data comes in the environment. In the right hand side, you see it is coming data, right? Yes or no? Are you able to do, everyone, up to this stage? Yes or no? Are you able to do up to this? Please confirm. Now I will show you the other alternative option that you have. If you struggle to do this, then you can do the alternative way, which is the easier way, and most of us follow that. But if you follow this approach, later on it will be easier. You can do things faster. It takes little time initially, but you can do things faster later on if you follow this directory approach. Okay. Is there anyone who could do it, or no one is able to do it? Yes or no? Please talk. Please confirm. Are you able to do it? Anyone?
Yes, sir.
Yes, sir. Yes, sir.
Yes. It is done. Okay.
Yes, sir.
Yes, it is done. Good. So you have done the first thing. If you are able to do it, it's great. Okay. Now suppose you want to, use the menu driven thing. That is also possible. Go to File, Import Dataset from Excel, right? And then you browse where your dataset is. Correct. Select this click open, dataset will come. Okay, this is another approach which is easier. Okay, so those who could not do it in the previous approach, please complete this like this. Okay, but make sure that you have the data in the environment. Please confirm everyone that you have the data in the environment. Yes or no?
Yes, sir, done.
Done. Good. Okay. Now, if someone is struggling, not to worry. This script will be shared with you. You can easily do it. Not an issue at all. Okay. And if you want me to share these scripts right away in the chat or in the WhatsApp group, that also can be done. The next thing that you need to do is you need to view the data, whether everything is imported properly or not, right? So one way is to write a code, view within bracket data, or you can simply click here. So it will also show you the data. Okay. Now can you see the data? Everyone, those who have imported the data, are you able to see the data, view the data? Yes or no?
Yes, sir.
Yes. Now you see, what is this I? I is the company ID, right? What is T? T is the year, right? And you know C is cost, Q is the output, PF is fuel price, and LF is load factor, right? Yes or no? And see how the data is arranged. So you have 15 years data for first company, right? So you see the I is equal to 1 till 15, right? Then it changes to 2. Then for 2 again from 1 to 15, right? This is how panel data is structured. Have you understood how the data is structured? So first company 15 years data, then second company 15 years data, then third company 15 years data, and so on. Okay, this is the structure in which panel data is arranged. Okay, so let me go back to the script again. Now we have seen the data. Now we have to run the models. For panel data model, we have one package called PLM. For panel data model, we have a package called PLM. So you have to install that package. So please install that package. Install.package PLM. Install that .package PLM, right? Please do it, everyone, quick. Install.package PLM. Same process. And always without default, after you install a package, load that package. Library in bracket, name of that package without the code. Please do it, everyone. Install.package PLM. PLM is the package for panel data analysis in R. And then load the package library within bracket PLM. Please do it, everyone. So I'm running this. And once it gets, installed, this red button will be there. Once that is gone, that means it is installed, right? Install.package PLM, library PLM. Done, everyone? Please confirm.
Still
Yes or no?
loaded, sir.
So should we type that hash panel data analysis?
Yes.
No. That is not required. That is for a one point that I need to explain. See, if you write any that has symbol and followed by a text, then R will understand that is a comment. That's not a code, right? And this is a good practice to write your comment against every code that you write. So even if I select the whole thing and click on run, R will execute only the code part, not the comment part, provided I have given the hash sign or symbol before the text. Is this clear to everyone? Basic difference between code and a comment, right? install.packages PLM, then library. Are you able to complete up to these two steps? Yes or no?
Yes, sir.
Yeah.
Yes, sir.
Done. Okay. The second thing, I know that I'm working on panel data. You know that you are working on panel data. But your machine, that is the software, does not know. So you have to declare your data as panel data, right? You have to declare your data as panel data. So how do you do it? This is the code that I use, right? P data is equal to P data dot frame within bracket data, comma, index is equal to P. I stands for the company ID and T stands for the year ID. So what I'll do, as these codes are getting bigger and bigger, I will just paste it in the chat or in the WhatsApp group. You can just copy and paste from there. That will, speed up the process, because we'll have to complete many things. Should I do that? Will it be more helpful for everyone? Yes or no?
Yes, sir.
Yeah. So as we go along and as the length of the code increases, so that is useful, because that will help, save lots of time, right? So let me just put that thing in the WhatsApp, this thing, so that everyone can. So you can just take it from here. I have already shared there. Okay, so just do it. Fine. So panel data, I'm just declaring. So what basically we are doing, we are telling that this part is very important. So in this data, we have done indexing, that I stands for the company identifier, and T stands for the year. So once I run this code, then R will understand that we are working on panel data, right? So once this is done, just select this particular code or place your cursor somewhere and click on run.
I'm getting this error.
You should not get the error provided you have typed everything correctly. Have you copied and pasted from the?
Let me check.
If any bracket is missing, then that will create a problem. Next is copy and paste. Okay. So now you see you have one more data in your environment, that is P data, right?
Same error, sir. Same error.
Okay. You have copied from the
WhatsApp.
But have you done these two steps, install.packages, and then have you run the library? Second command, both the command you have executed?
So I did it from the tools.
No, that is why I'm saying you follow exactly the way I'm doing now. Otherwise, this problem will happen. So
Okay.
this one, at least you have installed the packages, right? Install
Yes.
packages, .packages PLM, this step you have done.
That is done.
And then library PLM you have done.
Yes, sir.
Okay. And then the other things, upper part. So what I'm doing, I'll do just one thing. This is what, if you do not follow these steps, then this will be a problem. I can give you some steps from here to here. Okay. No, first of all, are you able to see your data in the environment? First of all, tell me that. If that is yes, then only we should proceed further. Otherwise, it won't work. Yes, please confirm that.
It is showing that PLM is not properly installed, something like that.
Okay, then you
Our
have
tool
to
is required to build our package but is not currently installed. Please download and install the appropriate version.
Okay. It's basically happening because of you are using some old version. You need to update that. Okay.
Okay.
So now you have to just watch how it's being done. You
Okay.
need to update it and then it will work. Okay.
Okay.
So you just need to update your this thing. The latest version is required, right? Anyways, I will give the script, so later on you can also verify, not a problem. Okay. Others are able to do it. It is working for them. Yes. Yes or no?
Yes, sir. Yes, sir.
Yeah, it is working. Okay, fine. So next, once this is done, now we are in a position to run the pooled regression model. Okay. So what I'll do, I'll just give you this code in the WhatsApp group. From there, you can just run it. Okay, because it is lengthy, and then we'll spend time in understanding the code rather than typing the code. Okay, that is better. That would be better utilization of the time, right? So I have given the code. Please do the clerical things, and then we'll try and understand what the code means. So we are basically running pooled OLS regression model. Model is equal to PLM, open bracket, T is the dependent variable, then this symbol, this is called tilde symbol, then your independent variables, one after another, Q plus PF plus LF, comma, data, which data? Data is equal to P data, comma, what is the type of model? Model is equal to pooling. I repeat, this model, this is a name that you can free to choose. Any name you can free to choose. It is up to you. Nothing, specific. Any name that you can give, that is model. I am giving the name model. Model is equal to PLM. This is the package I will be using, right? Open bracket. C is the dependent variable. Then this symbol followed by all the independent variables. We have 3 independent variables, right? Comma. You have to tell which data, on which data this model will be applied. So data is equal to P data, panel data, right? Comma. What is the type of the model? Model is equal to, within double quote, pooling. Okay. Please run. After this is done, please run. Are you able to run the model? Yes.
Yes, sir.
So what is
Yes,
pooling
sir.
implies?
Pooling implies it's a pooled regression model. Okay.
So are we not?
Pooling basically means, let me explain. Pooling basically means you are not giving, or you are not taking into consideration the individual heterogeneity that are there within the cross-sectional units, right?
But
You are
sir,
just
won't we do? But first, normally we first do the Hosman test to check whether we have to go for OLS or we have to go for FEM or
so
I.
that those things we'll discuss later. Don't
Okay,
worry
okay.
about it. So that is done while deciding whether we should go for fixed effect model or random effect model. So we'll come to that later. That is
Okay.
far from now. First this. Okay. Is it done? Then once the model is run, then you can click on this summary model. First you run this code and then run this summary model. So run. So it will give you the output. Okay. It will give you the output. Are you getting the output? Those who are able to follow, please.
Yes,
Yes,
sir.
sir.
Quickly. Yeah. Now, but you see in R, the way the output is thrown is not that great. Correct? So, but it doesn't matter because I can easily transfer this output into a CSV file in Excel, right? So how to do that? You can extract the coefficient and save it to CSV. So manually you do not have to type. You can take the main information from all the coefficient from here and export it into CSV. So what is the code for that? Write.csv I'm just sharing this code in the WhatsApp group. From there, you please check, and then we'll understand what this code means, right?
So can you share the codes along with the comments so that we can understand later on?
No.
Moreover,
Anyway,
you
this
have
will be
set the
given to you. All
coefficient.
the scripts will be given
Okay,
to you
okay, sir. Okay, sir. Okay, sir. Okay, sir.
Sir,
Thank you, sir.
moreover,
for
you
class
the
thing.
first code.
Yes, which one?
Coefficient is equal to summary model.
Yeah.
That code is skipped.
I just pasted in the WhatsApp group. You take it from there, and
Okay.
then we'll understand what it basically means. Run this code
No,
once it is
sir.
done.
I think you have not done. You have not shared one code, which is coefficient is equal to summary
Oh,
model.
this one. This one I
Yes,
did.
sir, this is what I'm saying.
Okay. First this one and then that one. Yeah, correct. So let us put this here. First you run this code. Let me give both the things. Okay. Coefficient. Okay. First coefficient and then. So first run this code. Coefficient is equal to summary model $sign coefficient. That means within summary model only coefficient you are taking, right? And then you can transfer this coefficient to a particular Excel sheet. And if you have got the working directory created, it will by default get saved into working directory. Okay, that's why I was emphasizing on the fact that you create working directory. It is going to be very, very helpful, right? So please run these two codes. Please run these two codes. Okay. Those who are proficient in R, please bear with us because I'm going a little slow for those who are working on R for the first time. So it's a it's a request that please bear with us so that everyone can follow to the extent possible, actually, right? So basically, I am just giving an instruction to take this coefficient, export this coefficient as CSV file, right? And this model, whatever name that I have given, model underscore coefficient, this part is your choice. Any name you can give, no problem. And then comma row dot names is equal to true means the row names will also be taken. That's it. Okay. So have you executed these two commands?
Yes, sir.
And now you go to your folder, that working directory folder, right? And see, can you find one file, CSV file with the name model underscore coefficient? Yes or no?
Yes, sir.
Is there?
Yes, sir. It is there, sir.
See, model in my directory, it is there. Model underscore coefficient. Okay. Click on that. Now you see, this is something very useful because you do not have to type. So it directly goes to the your Excel sheet, right? And in Excel sheet, if you have these numbers, what you need to do, you just need to select all this, Control-1, and change them to number. Change them to number. So basically all are 0. Basically all are 0. Okay. Are you able to get this in Excel sheet, everyone? Yes or no?
Yes, sir.
Now you see all your key values are less than 0.05. It means all these coefficients are highly significant and their signs are also in line with expectation. Say, for example, Q has a positive coefficient, statistically significant and positive coefficient, right? Because cost will have, positive relationship with what? Output. The more is the output, more will be cost. Yes or no? Right?
Yes, sir.
Similarly, fuel price for airlines. The more fuel price, more will be the cost. And load factor will have negative relationship. If your capacity utilization is more, then cost will be less. Yes or no? So signs are as per expectation and they are statistically significant. But we should not be, jumping with excitement that we have developed a beautiful model. Not necessarily. It is actually a very, very flawed model. I will explain why. Everyone could do this up to this, yes or no?
Yes, sir.
Yeah.
Yes, sir.
So we do not have anything to, celebrate. This is not a good model, though everything looks statistically significant, but it is strongly flawed. Why it is strongly flawed? Let me go back to the PPT and explain, right? So this is the number, these are the things were there. Now, why it is flawed? Can anyone tell what is the basic problem in this model? Anyone? What is the basic problem?
So in the model, we have assumed that beta 0 is like the intercept is common for every companies.
Yes.
But in general, it is not possible since
Yeah.
there is a problem heterogeneity. Beta intercept will also differ, sir.
Yeah. And you are right. But if you more technically, if I talk, see, we all know that every company is different, but we have not factored that in our model. We treated every company as same, same impact, right? That's what we treated. Since we have not treated that, those individual company specific heterogeneity are now sitting in the error term. Yes or no? Because what is error term? Error term is those factors which are not taken into consideration but impact the dependent variable. Yes or no?
So can you explain again, sir? Like, didn't get it.
What is error term? Error term in a regression model is basically what? The factors that you have not taken into consideration in the model, but are impacting your dependent variable.
Yes,
Yes
sir,
or
the
no? That is the
residual.
residual. Correct?
Yes,
Yes
sir,
or
yes,
no? Yes?
Yes, sir,
Yes.
they are the
Now
residuals.
I know that individual company specific factors should be incorporated into model, but we have not incorporated them. So they are sitting in the error term because I have not taken them into the model, right?
Yes, sir.
And if they are sitting in the error term, then error term is strongly, high possibility is there, then the error term will be correlated with the other regressors. Why? Because individual specific, factors will impact how they manage their cost, right? How, it will impact the output. Also, it will impact the capacity utilization, right? So what is this individual specific factor? It could be the company's management style or philosophy. Don't you think that will impact the way the company manage their cost? Don't you
Yes,
think
sir.
that will impact the way the company use its existing capacity? Don't you think that will impact their fuel procurement and purchase cost? Yes, it will impact. Definitely, it will impact, right? And if that is the case, then they are sitting in the error term. Then error term is going to be correlated with the other regressors. And if that is the case, then your regression model is useless, right? Because one of the assumptions of the regression model is that your regressors must not be correlated with the error term. So in fact, in this case, they are correlated. So this output you cannot defend. This is nonsense because you know for a fact that your arm specific fixed effects, individual effects are going to be correlated with the regressors, but you have not taken that factor into account. So this is a flawed model. Is this point clear to everyone? Yes or no? Is this point clear to everyone?
We can check,
Yes,
sir,
sir.
can you check for Durbin-Watson statistics also?
We'll do that. We'll do that. First, let us be, conceptually, on same page that this is a flawed model and it will create a problem, right? Is that clear to everyone? Yes or no? I'll show that, Darwin version statistics. So it is a flawed model. Is that point clear? Did you understand the, explanation that I gave? Why it is going to be a flawed model and why the error term is going to be correlated with the regressors? Is that point clear to everyone? Yes. Please respond. So,
So I have a doubt, sir. You said that
tell.
the country specific factors, I'm sorry, the country or the company specific factors we are ignoring in the particular model, then it will lead to the more it will increase the error term also. But how the error term is like getting correlated with the other regressors?
That is what I am explaining. See, what is error term? Error term is basically the factors that impact the dependent variable but are not taken into the model, right? Is that point
Yes,
clear?
sir. Yes, sir.
Now, since they are part of the error term,
Yes, sir.
and what is this individual form specific factor? Probably the management style, right?
Yes,
Which
sir.
is unobserved. Now, don't you think management style will impact your,
Cost.
output, cost, and the way you purchase fuel and all those things? It will. Yes or no?
Yes, sir. Yes, sir.
So
Yes, sir. Yes, sir.
if that is the case, then they will be correlated.
Yes,
And if
yes,
they
sir.
are
I know.
correlated, then you are violating one of the basic assumptions of regression, right?
Yes, sir. Understood, sir.
That is the point. Okay.
Yes,
And
Okay, sir.
I will show you with test also that actually this is a problem, right?
Okay, sir.
Fine.
Yes, sir.
So this is what I'm explaining, that you can say that individual some specific effect or individuality of each airline is subsumed in disturbance term or the error term. As a consequence, it is possible that the error term may be correlated with some of the regressors, right? And if that is the case, the estimated coefficients are going to be biased and inconsistent, right? So, and as I just told that one of the assumptions of the regression model is that the disturbance term or error term should not be correlated with the regressors, right? And more specifically, if you want to see how this is going to be a problem, let us revise this model and look right like this. So how this model is different from the first model that we wrote? Here I have included one new term, MI. What is that MI? MI is the management philosophy or the management quality, right? Okay, I have included that. Now, MI or M is time invariant, but it is varying across companies because different companies will have different management style, right? Yes or not? Management philosophy, different culture, which is unobserved. We cannot see, but it impacts the cost, correct? So in that case, what happened? It is time invariant. It is time invariant simply because though it is different for different companies, but within your sample time frame, it is not expected to change. We are expecting that the same CEO will continue for next 5-10 years or whatever it is, or at least the way they run the business, that will not change, right? So they are time invariant. So with time, that is not changing, but across different companies, it is different. Different company will have different culture, different management philosophy and things like that, right? But the problem with this is aim is not directly observable, it is unobserved. You know that every company's management style is different, but you cannot observe it, right? You can feel that difference. You know that will be a differentiating factor, but that it is not observable, right? The way you can capture the data for Q and all those things, it's not observable. But you need to put that thing into your equation, right? So what you can do indirectly, you can put that into your model. How? Instead of M, we can have one intercept term for each company. we have got something called alpha I. So alpha I, it is not having any T subscript. That means it does not change with time, but it is changing across company. So I is ranging from 1 to 6. So basically, we will have, 6 different intercepts, right? Okay. So what is happening here? Although such variable may differ among subjects, they will probably remain the same for any given subject over the sample period. This is the point I was talking about, right? Now, alpha is not directly observable. If it is not directly observable, we can treat, let us assume that it is random. If it is random, then we can add it with the error term, because error term, as per the regression assumption, error term should be random, right? So we will have now a composite error term, that is VIT, which is equal to alpha I plus UIT, right? And the equation can be rewritten like this. I have taken the alpha into VIT. Now you tell me, these consecutive terms of VIT are going to be correlated? Yes or no? Because VIT is including AI, which is constant, or alpha I, which is constant. So alpha I is there in this year's error term. Alpha is also there in the last year's error term, because they are constant. Alpha is constant. So naturally, this year's error term is going to be correlated with the last year's error term, and this will create an autocorrelation problem. This is the point someone was talking about, and we can prove that it is creating an autocorrelation problem. Okay, so is this conceptual framework clear to everyone? Why VIT will be having autocorrelation with its previous value? Because VIT is containing alpha I, which is constant. So it is there in this year's error term, also in the last year's error term. So naturally, this year's error term will be correlated with the last year's error term. That is nothing but the autocorrelation. Okay. So this is the conceptual framework. If you want to do the testing, then let us go back to the R and do the testing. You can easily figure out that there is autocorrelation problem. But before I do that, is this point clear to everyone? Please, someone please confirm if it is clear to you. Yes or no?
Yes, sir.
Yes.
It is clear?
Yes,
Yeah?
sir.
Yeah. So it is simple, because I have taken one time invariant factor as part of my error term. So the error term of this year is going to be connected with the error term of the previous year, because the time invariant factor is not changing, no? And it is part of the error term. So that is the problem.
Sir, these unobserved factors are always time invariant.
Yes, unobserved factors are time invariant, and that is the basic assumption in panel model that we do.
So, okay.
Fixed
So-
effects are that is why the name fixed effect is given now. Why it is called fixed effect? Because
Right.
they are fixed.
They are
These
fixed. They are
individual
time
effects are fixed. Okay. So
Okay.
they are different for different companies, but
But
over time they are fixed. Right.
sir.
That is why it is called fixed effect model. I'll come to that point. Right. Is that concept clear to everyone? Yes or no?
Yes, sir.
Yeah. So this part I have already explained, that how the error term going to be correlated and how it will be creating autocorrelation problem, right? So let us now do this in R, that will give the confirmation that there is autocorrelation problem. Now, so we have done till this, right? This model we have done, all those things we have done. Now, let me do few more things. We have done this up to this model we have already done, correct? Now let us take a look at how the residual looks from this model, right? So what I'll do, I'll just copy and paste up to this in your WhatsApp group. You can also copy and paste, because it will take a lot of time in typing, and then we'll understand these codes. I have done this. Please do the clerical part, then we will come back to the code and try and understand what is happening here, right? So please do that. First, I am extracting the residuals. So I should wait for, I think, a couple of minutes. Please complete, everyone, please complete, and then we can. Okay. Because it's a good practice to look at the residual, right? So let us, from this model, just look at the residual. Are you able to do it, everyone? Just copy and paste in your script and then run the codes. Run this residual, run. And then I need the density plot, basically. So residual density. Follow the same naming convention that I have followed, right? And then you plot. So are you able to get a plot similar to mine?
Yes, sir.
Yes, everyone?
Yes, sir. Yes, sir.
Yes. So you see, it is not perfectly normally, distributed, right? Yes or no? To some extent, okay, but it can be improved further, right? So let me just explain this code for plotting. Simply, the first code is you just create residuals from the model. So residuals, this is a name, any name you can give, equals to residuals, and then residuals of which model that you have to write. So we have this model, so model, right? And then you are calculating density, probability values of all these, what you call the probability density function for the residuals for plot purpose, right? And this is residual density is your name, any name you can give, and then you are using this density function to get the density values of the residual. And finally, you are plotting it. So you are basically plotting what? Which variable? Residual density. What is the name of your plot? That is main density plot of residual. What is in your x-axis? Residuals. What is in your y-axis? Density. What is the color? You can change to some other color. I have given blue. You can make it red, yellow, green, whatever you like. And this is the width of the line. Suppose here I have given 2. If I make it 4, what will happen? What will happen if I make it 4?
Width will go be broader.
See, can you see the difference? So width will be now thicker, right? Yes, that's it. So there's some decoration you can make if you want to, but it's not required at this point in time, right? So this is the code you understood, okay? Now, this part we wanted to, just add, but we had a bigger problem, that the problem of autocorrelation, and we need a confirmation that actually autocorrelation problem is there in this model. Conceptually, we are convinced that there will be autocorrelation problem because the individual form specific effect is clubbed into the error term, and individual form specific effect is constant over time. So naturally, error terms are going to be correlated. That is nothing but the autocorrelation in econometrics term, right? So for doing the autocorrelation test, we will rerun the model, right? Using LM model, and this is going to serve us another purpose, that this, when we use PLM and use the model type as pooling, we are effectively doing simple linear model. I repeat the point, you may make a note of it. If I am using PLM package and using the model type as pooling, it is as good as simple linear model, right? Because what is pooled regression? It is just a grand regression pooling all the observations without giving any importance to the fact that they are individually different. Either I am taking the form specific fixed effect into consideration, nor the time specific fixed effect into consideration. So it is as good as any basic regression model. So we can replicate the same result using the LM thing also. And I am using this simply because LM will be useful for calculating the autocorrelation. That is easier for us. Okay. So, and this will also verify that this LM model and this PLM model will generate the same output when I am using the pooling as a model type. Okay. So let me just, what I'll do, and we'll see that it is generating the same output. Okay. And then we will also do the correlation test, right? So I'll just put this in the, I have shared. Please do the needful, and then we'll come back to the output and see whether it is generating the same output or not. Okay. If someone is struggling to follow, not to worry, you will get the codes, understand the concepts and the process that I'm like that only. Yeah, correct. And let me see whether I can run this or not. Yes, yes. So PLM is already installed, so just do library PLM and then run this model, it will work. So install.packages PLM, right? It is already, I think, installed for you. Just call it library PLM, and then you can just run this.
Yes, sir. Yes, sir. Now it is working, sir.
Working? Yes?
Yes, sir. Yes, sir.
Ravinder ma'am, is it working now? So now your summary model, and you see you are getting exactly the same output. Yes or no?
Yes, sir. They both are same, sir.
Same. That's what I told, right? So
Yes.
in fact, in this case, you did not even do that pooling thing. That is the panel data model, because ultimately, if you are ignoring the individual company specific, effects, then there is no point working on panel data, right? So that is the basic point, correct? So now, you can just complete the rest of it, and you will see that it is giving you the same result, right? And you can also get these things, right? Not a problem. And now, so the rest of the thing you just complete, the plotting part and everything, whatever is there. Quickly run the codes, and then we'll move to the test. Okay, so you can see that plot is exactly same. Now come to this part, the autocorrelation part. The autocorrelation part. So we will now run. We will now install one package called LM test. This is for autocorrelation test. That is also known as the Darwin-Watson test. Okay. So please, should I just give these codes to you? Should I? Because that will save some time, right? I'm giving the codes to you. Have you got the thing? So first install this package LM test. Install this package LM test. Then library LM test. And then we have to perform the Darwin-Watson test. Okay. The null hypothesis of this test is residuals are not autocorrelated. That is, they are independent. That is the null hypothesis. Okay. So Darwin-Watson test. So please do not get scared about this symbol. It is going to serve the same purpose as equal sign. You can use also equal sign, not a problem. Okay. So just run this code and check, and then print the output. Are you able to get this output of Darwin-Watson test, or Darwin-Watson test rather? Yes. Yeah. Now tell me, whether autocorrelation problem is there or not.
Yes, sir, it is there.
Because your null hypothesis is saying that residuals are not autocorrelated.
So we are
Right?
rejecting the null hypothesis.
And you are rejecting the null hypothesis because p-value is less than 0.05. That means you are accepting the fact that there is autocorrelation. Yes or no? So it is confirmed now with test also. Yes or no?
Yes, sir.
Everyone got this point?
Yes, sir.
And this is what we were trying to conceptually, develop, that error terms are going to be correlated. It is quite natural because error term is now containing an item which is fixed. So it is there in this year's error term. It is also there in last year's error term. So naturally, this year's error term and last year's error term are going to be correlated. Okay.
So what is the hypothesis?
Hypothesis is residuals are not autocorrelated.
Okay.
This is the null hypothesis, and we are rejecting it.
So positive autocorrelation is there.
Yeah, there is a positive autocorrelation. Clear? Yes? Okay. Now, so we have all, criticized heavily the full regression model and all those things. The point is, there is no point criticizing it unless we come up with a solution, right? So what is the solution? Anyone? What is the solution to this problem? How can we develop a better model? What to do? Someone already gave hint. Yes. What to do?
The dummy variables.
Yes.
Least
The
dummy.
easiest thing to do is to include, dummy variable to represent each company's heterogeneity. Because we are accepting the fact that each company is different, and that should be somewhere captured in my model. If I do not do it, I will never get rid of this autocorrelation problem. And most importantly, my model is not going to be accepted by anyone because it is strongly flawed, right? So that is what we have to do now. That means once you accept that there is fixed individual effect, accepting is not going to help. You will have to incorporate that effect into the model. Unless you do that, it will sit in the error term and create problem. So you have to take it out of the error term and put in the model, right? So that's the basic idea. Okay. So let us proceed with the slides, a few more things. So this part I have already covered. This brings us to this concept called fixed effect least square dummy variable model, right? So what we are going to do now, we are going to recognize the fact that each company is different, and for each company we will have one dummy, right, to represent their individual differences. Okay, so this was our basic model, right? And now in look at this bi, and then there is a script I, right? B1I. It means what? Previously that I was not there. I was not there means what? Bi was constant. B1 was constant. Once I put the script subscript I, it means it will be different depending upon value of I. And value of I can be 1 to 6. That means we will have 6 intercept terms, right? Which represents their individual heterogeneity. Correct? Is this point clear to everyone? Yes or no?
Yes, sir.
And those intercept terms are basically suggesting what? Their management style, management philosophy, and the specific type of market that they are serving, and all those things. Individual specificness that is getting captured in those intercept terms, right? And in the literature, model 5 is known as fixed effect model. And this is the point I was talking about. The term fixed effect is due to the fact that although the intercepts may differ across subjects or entities, here that 6 airlines, each entity's intercept does not vary over time. It is time invariant. And it's a quite, sensible assumption to make, because the overall style of management is not going to change, right? Say, for example, if you think about at the country level, say India and US, the president of US might be changing, right? But their foreign policy is not going to change that much, right? They're more or less they are going to have similar sort of things. So that's what we are assuming, that in case of companies also, the top level management, once they follow a particular style, that is kind of going to be continued. That is the assumption we are making, and it's quite a valid assumption, so to say, right? But it is going to be different across different companies. Every company, say for example, Tata's have a different, culture from, and that is significantly different from Reliance, right? So every company, and over the years, whoever is heading Tata, that is not going to be that important, but that same culture probably will be carried forward, right? So that's what I'm trying to, say. Okay. So now this, how do you, actually allow for this different intercept into your model? As someone rightly said, that we incorporate dummy variables, right? To incorporate individual company specific heterogeneity. But there is a challenge. What is the challenge? That there is a trap called dummy variable trap. If you have 6 companies and if you add 6 dummies, then you will enter a dummy variable trap, simply because it will create perfect multi-collinearity problem. And no software can run that sort of a model, right? So to avoid that, what you have to do, if you have 6 companies in your, data set, then you put 5 dummies, and the intercept part will represent the company whose dummy you have left out. That is called reference. Okay. So you can see here I have taken D2, D3, D4, D5, D6. No D1. That is actually getting represented by alpha 1, right? And once we run the model, and then I will show you, and I will also reconcile the things that I'm talking about, right? So as I just said, that we have 6 airlines, we have introduced 5 dummy to avoid falling into the dummy variable trap, which is basically a perfect collinearity problem, right? And as I just said, the airline 1 is treated as the base or reference category, and we can choose any airlines for that matter as the reference. So it is not that you have to always drop the first one. You could have dropped the second one, right? In that case, your intercept will represent the second one, right? You could have dropped the third one. It's your choice, not an issue at all. But it is important how you interpret the coefficients, right? So this alpha 1 is basically the intercept value of airline 1, and other coefficient represents by how much they are differential coefficient, by how much the intercept values of other airlines differ from the intercept value of the first airline. So this will be much more clear when I actually estimate the coefficient and show you the math, reconciling what I am talking about. What I'm saying is, whatever value that we get for this alpha 1, that is representing the individual specific effect of airline 1. But the coefficient of D2, that represents by how much the individual effect of the second company differing from the first company, right? So these are all differential. These are all differential. We'll do the math and we'll crack that thing. You will get it, right? So say for example, alpha 2 tells us by how much the intercept value of the second airline differs from alpha 1. So what is the actual impact of second airlines? It is nothing but alpha 1 plus alpha 2, right? Because alpha 2 is the differential and alpha 1 is the base. So base plus the differential will give you the actual value for the second airline. So we'll do that math, it will be clear, right? So we have to keep in mind that if we want to introduce a dummy, but some of you may be very particular that I want one dummy for one company, each company. So in that case, what you have to do? You have to drop the intercept part, right? So if you want 6 dummies, then you have to drop the intercept part. So that is the another solution, right? So keep in mind that if you want to introduce a dummy for each airline, you will have to drop the intercept part. Otherwise, you will fall into the dummy variable, right? So these are the outputs. So let us go back to the R and generate this output, and then in one Excel sheet we will just reconcile the numbers so that you get what I am talking about, right? So can I go back to the R? Yes or no? Ready?
Yes, sir. Sir, I
Yeah.
have a doubt, sir. I want to ask
Tell.
something.
Mm.
Sir, if you, as you said that if we can drop the intercept, then with which value we will be considering the differentials? Like in earlier case, we used to
So in
take
that
the
case, the coefficients are no more differential. It is actual total.
Oh, acha, acha, acha. Okay, sir.
I'll show it. I'll show the numbers. You will understand.
Okay, sir.
Right.
Okay, sir.
So if I have the intercept, then the coefficient of the other dummies are differential. If I drop the intercept, then they are no more differential. Because to make the differential, you need to have a reference. Now, if you drop that reference itself, then what is the point of talking about differential, right? So let us first, estimate the coefficients, and then we can reconcile what we are talking about. Okay. Are you ready? Can we go back to? And some of you might be little disappointed seeing the plot of the residual that it is not looking like normally distributed. But I guarantee you, when we end the session, we will end up with a plot which will look like normally distributed. Is that okay with all of you? Yes or no?
Yes, sir.
We will develop because that's what I said, that we will add on new things into our model so that we can improve the model, so that we end with a happy note. Okay. So let us proceed. We have 1 more hour to go, so we'll do it. Okay. So fixed effect model with dummy variables for airline. So what is that model? Let me do it one thing. First, let me just give you the codes so that we can save on the typing part and all those things. And then we will talk about the codes. I think this approach is okay with all of you, right? Because we are, you can save on the time, right? Okay. So I have given it. Just do the coding part, and then I will explain the codes. So we have fixed effect model with dummy variables for airlines. Just do the codes, everyone. And then we will see what we can do. Once done, please let me know.
Done, sir.
What about others? So the first code, you see, I have named the model as LSDVM, least square dummy variable model, right? Correct. And for this, we can use LM function because we are using a dummy variable. It is like a normal regression model, right? And LM package, same process, dependent variable tilde followed by the independent variables. But now we have one new item, that is factor I. What is I, if you recall? I is the company identifier, company ID, right? Yes or no?
Yes, sir.
So this will create these many dummies, correct? But software by default will drop one dummy because it knows that if it takes all the dummies, there will be perfect collinearity and it cannot run, right? So this part will take care of the dummy part, and then this is simple. Data is equal to that panel data, right? And once you run this, please
Sir,
run this code.
in linear model only, we are just
Hmm.
including factor I. That means
Hmm.
factor I will incorporate dummies for the identities.
Yes, yes,
Factor
absolutely.
is a command for dummy variable,
Dummy variables, yes. Categorical variable, yeah.
categorical variable.
Yeah,
Fine,
categorical.
got it. You're right.
Yes. Okay. And then you just run the summary model, right? And then you can have the coefficient table. These names, you can give any names, not a problem. Coefficient table, let me run. And then let me take it to the, okay. And you can run the residuals also, same way. And you get the plot. Now you see this improved the plot, no? Yes or no?
Yes,
Can
sir.
you
Better
see?
than before. Better than before, sir.
Better than before. So this is a proof that once you take the individual company specific fixed effects out of the error term and put in your model's explanatory power improves. That means your error starts to behave more normally, right? Yes. Can you see that? And we will even get rid of this till by the end of the session. Okay. So everyone is able to get this? Yes or no?
Yes, sir.
Yes. Are you able to get this plot? At least those who are following. Otherwise, you just follow me and understand the concept. Later on, you can do it. Okay. Now, as some of you are very, very particular that you want to have one dummy for every company, that is also possible. How to do that? In that case, you'll have to drop the intercept. And how to do that coding? This is how it has to be done. So I'll just give you this. I'll just give the codes. So please do it. And then we'll do the reconciliation part, right? So please complete that these codes, and also you also have the codes, right? So from your thing also you can copy and paste. Only change that you have to make here, but better you take it from my this thing codes. Once you are done, please let me know. I'll explain the difference in the codes. Done.
Yes, sir. Done, sir.
Done. Yes. Others, those who are doing.
Done, sir.
Okay. So just what we have done, you see, here we want to drop one intercept, right? That is the intercept part. To ensure that the intercept part is dropped, you have to just do this adjustment, -1, right? The way we have done it. So let me just run the codes. That's the only thing. I've just given some names as per my choice. It is not going to make any difference. Residuals, density plot and your density. Okay, and you see the plot is exactly same, right? So basically we are not doing anything different. Two approaches to tackle the dummy, right? Okay. Now you have both the numbers in your directory, right? So let me go back to directory. So you have what are the two model names that I have used here? One is this one is your coefficient. It is LSDVM, this model CSV. Okay, so this is one. Okay, convert. This is with intercept and without intercept. What is the name that it have used for without intercept? Okay. Without intercept, what is the name we have used for without intercept? I think LSDVM 1, right? Yes. This is without intercept, right? Yes or no? So now I'll just copy this and paste it in the other sheet and we'll do the reconciliation part. Okay. Oh, where is it? Okay, with intercept and without intercept, right? Now you see what I said that with intercept, this intercept is representing what? Factor 1? Yes or no? Yes or no?
Yes, sir.
Exactly same answer, right? And factor 2 will be equal to this plus the differential, and this will be given as absolute reference,
Yes, sir.
right? And are you
Yes.
able to see it's same, right? And if you just drag it, you will get that, right? Are you able to reconcile what I just said? Yes or no?
Yes, sir. They are the sum.
So when I use with intercept, the other factors, coefficients are representing differential. So if I add the differential with the base, I will get the actual number, right? So this is what I was talking about. Is it clear now? Yes or no, everyone? Basically, we are doing the same thing, but which is the common practice? The common practice is the differential approach. Okay, right? Because we would like to keep the intercept and we will treat the other coefficient as differential. Is it clear to everyone? Yes or no? Hello, is it done?
So can you just
Understood.
explain this process?
Which one? Just come again.
This coefficient thing which you have the difference part.
So what I'm saying is, when I am using the intercept, that means in this case we have 6 companies. I am using 5 dummies and 1 as intercept, which is representing the company that I have left out, right?
Yeah,
In that
yeah.
case, your intercept represents the company that is left out, right?
Yeah,
And other coefficient represents the differential coefficient, differential impact. That means if you want to say, for example, if you want to calculate what is the individual fixed effect for company 2, that will be the intercept plus this differential, right?
Yes.
Yeah. Similarly, if you want to calculate what is the impact of company 3, that will be nothing but that intercept plus the differential impact of 3, right?
Yeah.
Correct?
Yeah. Yes.
But when you are dropping the intercept, if you drop the intercept, whatever numbers that you are getting, these are the total value, total impact. These are no more differential impact. Can you see that these numbers and these numbers are same? These numbers and these numbers are same, right? This is the
Yes.
point I was
Yeah.
making. Is it clear?
Thank you, sir. Thank you.
Okay. Is it clear? I think it's clear.
Yes, sir.
Yeah. Okay. Fine. So let me now go back to our discussion that we were doing. So now let us try and figure out, is there any way we can improve these models further, right? Because though we have come closer to normality, but still it is not satisfactory. So let us do something to improve the normality part of the residual. So what we can do, till now we have considered only one-way fixed effect model, but we can think about a two-way fixed effect model, right? So what is that? Two-way fixed effect model means, one-way fixed effect model is when we are taking the individual effect, individual company specific effect into the model. That is one-way fixed effect model. But if you also take the time fixed effect, that means if you also include the time dummies into our model, then it will become a two-way fixed effect. One-way fixed effect model means individual company specific dummy, and two-way fixed effect model means you also have time dummies into the model, right? So that is what I'm saying. Model 6 is known as one-way fixed effect of a model because we have allowed the intercept to differ between airlines. But we can also allow the time effect if we believe that the cost function changes over time because of factors such as technological changes in government regulations and tax policy and other such effects, then we can include that as into the model. And such time effect can be easily accounted for if we introduce time dummies, one for each year. But again, same principle will follow. Since we have 15 years data, we will include 14-year dummies, right? And if you do so, then the model that we will get, that is called two-way fixed effect model, right? Okay, so let us do that in R. How to do that in R? Let us try and do that. So what I'm doing now, include both individual and time fixed effects using dummy variables. So I'll just give the codes to you, and then rest of it we can do it and see whether this improves our result or not, right? So where is my okay. I have given you the codes for two-way fixed effect model. Okay. First do the coding part and then I will explain the codes so that you can understand what is going on. Once you are done, please let me know. I have named the model as LSDVM2, right? And you can see that now we have factor I as well as factor T. Factor I for company specific dummies and factor T for year dummy, right? Rest all are same, right? let me run these codes. First one we have done, second one, and coefficient. Write the coefficient as CSV. Residuals. Then, and finally, we'll plot it. What the problem is, are you able to do it till this? Are you getting the same steps like mine as
Yes, sir.
for the residual plot? Yeah.
Yes, sir.
But you see, it did not help. That means including the time dummy does not guarantee that it will improve your model. And this can be verified from the fact that if you see the output, what is happening? Your ER dummies, almost all your ER dummies are not statistically significant. Can you see that? Yes or no? Can you see that? See the p-values for ER dummies.
So yes, sir.
So it basically means there is no point including ER dummies. That will not going to help. Is this point clear to everyone? So this is a wrong notion that we have, that two-way fixed effect models are always better than one-way fixed effect model. Not necessarily. Because if the time does not have, it depends on what variable you are modeling, right? Time may impact, but it is not a guarantee that it will happen. But we can do further modification and also make use of this. So I will talk about it. But is this point clear to everyone?
Sir, I have
That-
a question.
Yes, please ask.
Sir, including dummies for companies means we are trying to incorporate firm-specific heterogeneity.
Yes.
And when we are including dummies for time, that means that our unobserved heterogeneity is time variant.
Yeah, a part of, see, with time also there is some variability in your outcome. That's what you are saying, basically.
Yes, sir.
Yeah.
So,
Correct.
so this is what I was asking, that is it necessary that unobserved heterogeneity is always time invariant? That means it can vary along with time.
No, unobserved heterogeneity specific to cross-section is always time invariant.
Okay. Specific to cross-section is time invariant.
Cross-section is always time invariant, right?
Okay.
But your dependent variable may also get impact because of the changes that happen over the years, right?
Right, sir. Right.
That part is the time effect. Okay.
Okay, sir. Okay. Got it,
And
sir.
your dependent variable also might get impacted because of the individual company specific heterogeneity. That is the fixed effect that we are talking about, right? Okay. Understood?
Yes, sir. Yes, sir.
Yeah. And this time fixed effect is changing over time but fixed across cross-section. Understand the concept carefully.
Yes, sir.
Because if there is a policy change, regulatory policy change, that is changing, but it is going to be the same for all the cross-section units. Yes or
That is
no?
why it is fixed effect time.
Yes. That is why it is called fixed time effect.
Fixed time effect, right?
Okay. So it is changing over time, but it is fixed for all cross-section, right? And in the other case, it is not changing with time, but it is changing with the cross-section. Is that point clear to everyone? So if you are not very clear, it can create confusion. Is it clear? Clear
Sir,
now?
can you please repeat, sir?
I am repeating. Say, for example, what is meant by time fixed effect? It is nothing. Say, for example, the government is coming up with some new regulations, some changes are happening, some technological changes are happening, and all those things. And these changes are going to impact all your cross-sectional companies or units. Yes or no?
Yes, sir.
So for them, this impact is fixed, but over time it is changing, right?
Yes, sir. Yes, sir.
This is why it is called time fixed effect, right? But other thing that we talked about, that is individual fixed effect. So individual fixed effect is over time it is fixed, but across different cross-sectional units they are changing. That is management style, different for different companies. But over the time it is expected to remain the same, right? Is it clear?
Yes, sir.
Yeah, this is the catch. So this
Understood.
is very tricky. Unless you have absolute clarity, it is easy to get confused. Why the term fixed is used? One side we are saying it is changing with time, but still we are saying time fixed effect because it is fixed for the cross-section units, right? Okay. So I hope this is clear. This part is clear. Yes or no? So let us proceed now. Do not get disheartened that we could not improve the model. We'll figure out something else and definitely improve the model, right? So what to do now? Can anyone suggest how to improve this model further? Because we tried, fixed effect, individual fixed effect, time fixed effect, right? But it is still not up to the mark. Any suggestion anyone has that can improve the model to some extent? Yes.
64,
Anyone?
wherein we'll be taking d-mean data.
D-mean data, but ultimately you will get to see in the next class that D-mean data will do next class, that it is no different from the estimates that you are getting using this least square dummy variable method. Okay, that we will discuss next class. So any other thing that, because see, that is also fixed effect model, this is also fixed effect model, right? So this is not helping much. It definitely improved to some extent because it is far better than what we got from your pooled fixed effect model, pooled regression model. But we need to improve it further. Any suggestion? Any transformation that can help, especially those who are from economics background?
Log
You should tell
transformation.
me.
Log
Yes.
trans
Yes. The best thing to do is to do a log transformation, right? That might help, but there is no guarantee. Sometimes we might have to do power transformation, log transformation, but always remember this thing, that this is always a trade-off. Once you do the transformation, then your interpretability will be little compromised, right? Because you are tampering with the your main data, right? But it will improve your model diagnostic. Right? Your model will be statistically much more sound. That means you can defend the model, right? But you lose little bit of interpretability if you do too much of transformation and all those things, right? But it's a call that you have to make, that what is more important for you? Is the relationship and the soundness of the model more important, or the interpretability is more important? So it's always a trade-off. But in research, generally we give much more focus on the soundness of the model so that this can be generalized. When we are trying to, develop a relationship between two variables or trying to see what is the impact of one variable on another, that whatever model that I am, using to, come to that conclusion should be, generalized, or should be, generic, which can be applied to other, companies or other, scenarios as well. So in that case, we should go ahead and transform our variables and get the model fit better, right? So this is always a trade-off. There is always a trade-off. There is nothing called right or wrong, but model transformation is a common practice, and in all research work we do it. We also do things like windsoring, just to reduce the outliers to some extent, but there is a limit to it. But transforming data is a very, very common practice, and log transformation is pretty common, right? Provided we do not have negative values and all, then we can go for log transformation. Okay. So let us do the log transformation and see whether things improve or not, right? And I'll give you the code. So first we will get the log version of these variables, right? I'm just giving you the code so that we can just replicate it. and then we can come back and understand what's going on, right? So I have given you the code, just run the codes and then we'll talk about it. See, the naming convention and all, it's up to you. It's not a problem. So whatever is there in the left side is your choice. Right side, not your choice. You have to follow the, structure. And this symbol, don't get confused. You can use plus equal sign also, not an issue. Okay, so let me also run the code side by side and then we'll talk about the result. I have named this model LSDVM underscore log. Your choice, you can give some other names also, right? Summary log, coefficient, then let us come to the residuals. Okay, and finally we'll plot the residuals. Are you getting a plot similar to mine? Yes?
Yes, sir.
Yes or no?
Yes,
Has it
sir.
improved the
Yes.
normality to some extent? Yes,
Yes, sir.
it has improved. It has improved to some extent. Yes or no?
Yes, but it went peak, sir. Like it is more peaked.
But it is still not satisfactory, right?
Yes,
It's
sir.
still
Yes,
not
sir.
satisfactory, but it is still it is better than the previous one, right? Yes or
Yes, sir.
no?
Yes, sir. Yes, sir.
Do you agree with me? It is better than the previous one. So we are making gradual developments, right? Incremental development in the model, right? Okay.
Yes, sir. Permutation
And
combinations.
yes, and to be honest, this is an art more than science, right? Because there is nothing called the tried and tested method of getting a very good sound model, right? You have to try different combinations, and that is where the researcher skill is involved. Otherwise, so everyone will get the codes and run the code and get the model. It's not going to be like that, right? What all transformation you need to do and selection of variables also, right? Because this may be due to some variables we have missed out, right? That omitted variable bias, which is who told you that only those 3 variables are impacting the cost of running the airline? Necessarily. So there might be omitted variable bias also. So model specification error could be there. So there are n number of other things could contribute to this problem. But that is where the challenge is in research. It's not predefined. That there is nothing called, okay, if you follow these steps, you will get the best output for your model. Not necessarily. Okay. So what we can do now? Now I will do one thing, and then we will stop because it's been too much for the first day. Okay. So what I'll do? This was what model we used? One way or two way? We used one way model, right? Yes or no? Just look at the codes. We have taken the log and we have used factor I. That means we have just taken into consideration the one way fixed effect model, only taken into consideration the individual fixed effects, right? Yes or no?
Yes, sir. Yes, sir.
But let us try out two-way fixed effect model and see whether things improve or not with log version. Okay. Should we do that? Should we try? Yeah.
Yes, sir.
Yeah. Okay. So don't get disheartened that that time fixed effect could not improve the model, but bear in mind that was raw version, raw data, right? Not the transform data. With transform data, it could be a different story altogether. Let us try. Should we try? Yes or no?
Yes, sir.
Yes, sir.
Should we try? Yes, we should try. Let us see. There is no harm in trying, right? At the most we'll fail. That's okay, right? because it's a trial and error approach, right? So let me give you the codes, and then we will see whether our luck favors us or not. Okay. So let us go to the, okay. I have shared the code with you. Now just do the needful, and then we will discuss the code and the outcome. So you see, I have named it as LSDVM underscore log1, right? Almost everything is same, except I have now included factor T just to bring in the time dummies, right? So everything else is same. Last half an hour, we will discuss if you have any specific doubts that we can discuss. Those who could not do the coding side by side, don't get disheartened. I'll give you all the codes with all the comments and all. You can run them at your convenience. If you have any doubt at any point in time, even if it is after the FDP gets over, please feel free to ask me. I will definitely help.
Model as in,
See,
yeah.
see, now I think most of us will be quite satisfied with it, right? Yes or no?
Yes, sir.
Yeah, this is what we were all kind of looking for, right? Yes, yes. Partho, are you getting similar plot
Yes,
as
sir. Yes,
mine?
sir. Yes. Yes, sir. Yes, sir.
Yeah, this has improved significantly,
Ye-
right?
Yes, sir.
Yes or
Yes,
no?
sir. Yes, sir.
So
We
this
have
is
got.
what
We have
I meant.
normal, sir.
Yeah, it looks like normal, right? Right
Yes,
now.
sir. Yes, sir.
So this is what I meant initially, that the pooled OLS regression is just a starting point. It is highly flawed model, right? And now, can someone tell me when pooled OLS regression will be actually useful? Any situation where it is useful? What is the prerequisite?
So,
Anyone? Apply a little bit of your thinking and tell. So
If
in
we-
general, it's going to be useless because of the correlation between error sum and the predictors, right? But in which situation OLS, pooled OLS will also make sense? Can anyone tell me?
when the all firms are homogeneous.
Yeah. If there is no heterogeneity across firms, then pooled OLS is good enough, right? And it is not something that totally, out of the question, because if a particular sector is highly regulated, very highly regulated, then every company behaves the way the regulator wants. Then individual company specific variability may be very, very minimal, right? In that case, pooled OLS still can make sense. Very chance is very less, but in that kind of a scenario, it is possible, right? So suppose every company is managed by a regulator, and by and large, every company's management style is same. So in a highly regulated industry, this is still possible, but possibilities are rare, but it is still possible. It is very much possible. Okay. So we'll stop at this. If you have any questions, anything on whatever we have discussed so far, then feel free to ask. I will be happy to answer.